Hey mathematicians, we're going to talk about prime factorization, which is when we break a number down into its factors, but all those factors are prime numbers. Now, I don't know why, but for some reason, this is one of my favorite topics. I think because it's super helpful when we get to fractions and we have to simplify fractions. If you are really comfortable with prime factorization, simplifying fractions becomes super easy. So pay extra close attention today because this is going to come in handy throughout the whole rest of the year. All right. So prime factorization is writing a multiplication sentence or an expression of a composite number as the product of prime numbers. So remember, product means the answer to a multiplication sentence, and that multiplication sentence is only going to include prime numbers. Some of our most common prime numbers, 2, 3, 5, 7, 11. Maybe we'll get a few bigger ones, but those are the most common ones we'll use. A factor tree is a way to help organize your work when you're decomposing into your prime factors and help you find your prime factorization of a number. So let's show you an example of what that looks like. So if I take the number 45, I want to break it down into a factor pair of 45. Oh my gosh, why do I always struggle to find my, here it is. So what I do is I'm going to break it into two factors. The nice thing about factor trees is it can be any two factors of 45. Well, let me take that back. Almost any, because if I wrote 1 and 45, 1 is not a prime number, and 45, well, that didn't help me simplify because it's just there as 45. So 1 in itself, not going to use, but any other factor pairs, we can use those. Okay, so what are some other factors of 45? Where am I? Oh my gosh, I'm always over there. Okay. Here we go. What about, oh, I know that 9 times 5, that's 45. So you can choose to put your time symbol there if you want to make it super clear. I'll be totally honest with you, I don't always do that. But the really important thing is I want to circle all prime numbers. 9, is that prime? No, that's composite. 5, yep, prime number, because the only factor pairs for 5 are 1 and 5. So I'm going to circle it. And that kind of branch of my factor tree is done now. But this 9, I can keep breaking down. 9, okay, my factors of 9 are 1 times 9, that doesn't help me, and 3 times 3. Is 3 a prime number? Yes, so I'm going to circle it. Is 3 a prime number? Yes, so I'm going to circle it. When all my branches of my factor tree are circled and I can't keep going, then I'm done. I have my prime factorization. Now you can't just circle this and be like, that's my answer. You have one more step to do. We're going to write it out. 3 times 3 times 5. And sometimes if I have really big numbers, what I'll do is I'll write my 3 and then I'll cross it off on the factor tree. And write my next 3 and cross it off. Just to make sure I get them all, because sometimes we have doubles, like we have extra 3s. We have 2 3s here. So this right here, 3 times 3 times 5, is my prime factorization of 45. Notice how I started with the smallest factor and went to the biggest factor. Another thing is that when the same factor is repeated in a prime factorization, you can and should use exponents. So if I go back here, I could use exponents and write this as 3 to the power of 2 because I have 1, 2 3s times 5. This is an even simpler way to write your prime factorization for 45. Both of these are technically correct. I do want to push you to practice with exponents. That's what I'm expecting if you're writing it out. So we have exponents. Let's try, 250. One more example. Here we go. Now, if it's divisible by 10, that's my go-to. I know that because it ends in a 0. I'm just going to start with 25 and 10. The great thing about this, though, is if you didn't see that and you wanted to start with 5 as a factor, 5 times 50, you could do that. And by the time you get all the way down to the end of your factor tree, we'd have the same answers. 25 is made up of 5 times 5. Notice I got kind of lazy and I dropped the times symbols. It's up to you if you want to include them or not. This 5 is a prime number, I'm going to circle it. This 5 is a prime number, I'm going to circle it. 10 is 2 times 5. 5 is prime number, 2 is prime number, circle it. Okay, so I must be done. But just to prove my point over here, here's 250. Let's say if we started with 5 and 50, I'd circle this 5 because that's prime. I'd decompose this 50 into maybe like 5 times 10. Circle that. 10 is 2 times 5. And notice how this tree looks different, but at the end I still have 3 5s and a 2. I would write it from least to greatest, which means I'm starting with my 2, times, and I can even cross off my 2 because I've used it. 1, 2, 3 5s, so 2 times 5 to the 3rd power. That is my prime factorization, or if the problem doesn't say like write it in exponents, you could also write 2 times 5 times 5 times 5. That is also correct. And that's our prime factorization.